Okay, so we're going to continue talking about arrays today. There was a question, however, about structs, so I thought I'd talk about that for a minute. The question was, what's the difference between a struct and a class? And there's a couple different ways to answer that. Do you want to know technically in C++ syntax, or not syntax, but according to C++ rules, what the difference is? Or the other possibilities, you may want to know what the difference is in terms of how it's typically used or how you ought to use it, right? Both, right? Let me do the actual difference first, because that's actually pretty simple. They're almost as far as the compiler is concerned, they are exactly the same thing. Whether you put class or struct, it's exactly the same thing, except if you don't put the word public or the word private before one of your members. So when we do classes, we always put private or public before all the members, right? So we don't, this doesn't come into play. But the default in a class, if you don't have the word private or the word public there, the default is private. In a struct, if you don't have the word public or private there, the default is public. Okay? So another way of saying that is, because when you're doing classes, you're always going to put private and public there anyway, the actual difference between a class and a struct makes absolutely no difference to you, right? Because you're always going to have either private or public there. In terms of how they're used, so the struct came before class, so struct was basically, back in the old C language, struct was all there was. It didn't have class. And so whenever you wanted to write something that we call a class, you would use a struct to do it. And there was no way back then to make some of your members private. So you didn't have encapsulation that we have with C++. So basically, the time that you're going to use a struct would be if you're just you want to group some data together, but you don't really want to get really fancy with it. You're not going to have member functions that operate on the data. You're not going to try to use private so that the program can't access it. It's just very simply a way to connect two variables together and make one variable out of it. That's all a struct is. That make sense? So in assignment, that has to do with counting the number of letters in something that the user enters, what you're going to do is you're going to create a struct that has two variables in it. So you could call them data members. Normally that's a sort of a terminology that you'd only use with a class, but it's the analogy to two data members. One is going to be a letter, and the other is going to be a count of the number of times that letter has been seen in the input. So you're going to create a new type using a struct, and then when you create your array, instead of your array being of type int, like it has been in all of the examples I've done, I think, your array is going to be of type whatever that new type was that you created, right? So in other words, if you say struct, I want you to try to think of a good name for it, so I'm going to call it X. Struct X, and then you're going to have int first field. Okay, I'm using bad names because I want to give you a chance to come up with what you think is a good name. And then car second field, and then a semicolon, just like you would with a class, right? Okay, so that looks an awful lot like a class, except I have the word struct there instead of the word class. I don't have the words private or public inside. In a struct, they are, I don't think I've ever seen anyone use private or public in a struct. There's always public, yeah. If you want private, you probably should just use a class. Yes. Yeah, right. Right. It's kind of like an array, except the elements are named. That's exactly right. So you could do a compare and contrast between arrays and structs. They're both ways to combine variables into a single larger variable, right? With arrays, all of the components have to be the same type, and the way you access them is with an index. With a struct, they don't all have to be the same type. You have to list each of the components separately so you don't access them by an index. And that's basically the difference between an array and a struct, right? They're both ways to combine little variables and make bigger variables out of them. Yes? Right, right. So if you wanted to declare an array of these, and you call it, I'm going to call it Y. Now I'll call it list. That might be confusing. So X list 100 or whatever, right? Because normally in all the examples we've done, what we've had here is int. Yeah. So, well, not quite. Okay, so the next question is, so all of the examples that I've done, I don't think I've ever realized this, but it might be nice if I actually did some examples where the elements were something other than an int. But, so let's say we're in main now, and we want to say, we want to put the character A into this second field of element number 9. So let me write that. Put A into the second field of element number 9. Okay? So you start with, what are you going to start with? Good. Right, so you basically start with the big variable. So basically we've got nested things here, right? We've got a struct nested inside an array. You start with the biggest variable and you drill down. So list, and then which element of list do we want? 9. And then the way we access one particular component of a struct is the same way we would do it with the class, just a dot. So this is a selection operator. So dot, and then what is the name of the data member that we are trying to access here? Second field. Whoops. How do you get there? Gets A. Okay, so the next question is, if it wasn't in a list, how would you do it? Remember, X is a type. So you're never going to actually say X dot something, because X is a type. So I would have to declare a variable of type X. Say X, my variable. That make sense? That shouldn't be too, I mean, it might look a little mysterious because you're not used to seeing a type named X, but that's just a type like int or car or whatever. So I'm saying X, my variable, and then I might say my variable. My variable is a struct, right? So how do I get to one particular component of a struct? How do I select one component of a struct? Dot. The selection operator, dot. My variable dot first field gets 19. Whatever. Right. So you can't say X dot something. You first have to actually have an object of type X. Right. All right. Any other questions about how that's going to work? So you're going to read a letter, and what are you going to do with the letter that you read? And this is maybe some of you haven't read the assignment. Probably most of you haven't. How many of you have read the assignment? Okay. So basically what you're doing is you're counting the number of letters of each letter and some input that the user types. And I'm going to actually just take a look at it real quick here. This may save some people some time, so. Okay. So, use an array with a struct type as its base type. That's what I just showed you how to declare. So that each array element can hold both a letter and an integer. That's what we just did. In other words, use an array whose elements are structs with two fields. Okay. Do I have these sections right? Yeah, I think I do. The integer in each of these structs will be a count of the number of times the letter occurs in the user's input. So what's going to happen when you read a letter? Run that by me again. Right, right. That's the objective, ultimately, right? But I guess my question is, each time we see that letter, how are we going to? What do we have to do so that when we're done, we have that information? We know how many times it occurred. So, okay, so sorry, go ahead. No, I am. Well, so I think, sorry. What we're talking about here is, it sounds like you know, like ultimately how you want things to look. So my question is, more specifically, each time we read a letter, what exactly are we going to do with that letter? Increase count by 1, but we're just going to have a variable named count, and we're going to increase it by 1. So we need to look up which array element corresponds to that letter, and then increment the count that's in the same struct with that letter. Does that make sense? Let me draw a picture. Any excuse to play with paint. Okay, this is actually pretty important. This is a picture that I should you probably shouldn't get through CS10 without seeing a picture like this. So, here's my array. Big array. Oops. Nope, that's not what I wanted. Shapes. Line. I'm getting smaller and smaller, huh? Okay, this is, and it keeps going, so this is not the whole array, right? And so you're going to have, and then each of these arrays is a struct. Each of these array elements is not all of the other arrays that I've drawn. Each of those elements was just an int, right? This time, each one of those elements is a struct. So I'm going to indicate that by kind of putting a line through here to show that each of these array elements has two parts. Okay, so let's say the top part is where the character goes. So what's going to be in this element? A. And what's going to be there? B. And so on. You get the picture, right? Okay, and then what goes down here is how many times we've seen that letter. So when we start, it's going to be 0, 0, 0, 0, and so on. And if we see the letter B, what are we going to do? Increment this guy right here, right? So we saw B, so I increment that to 1. Okay? Yeah. So there's a lot of different ways to do this. Some of them are definitely better than others. I'm never quite sure how much direction to give you because part of me wants to let you try to work on it and see if you can, come up with some code and then maybe look at it and go, you know what, there's a better way to do this. But basically, I think probably the best thing is going to be to preload the whole array with the A, B, C, D, and so on. And then let me just say this about the rest of it, okay? Significantly more than half of the programs that I get on this assignment, the students actually read a letter, and then they have a loop that goes through the array looking for that letter. And then when they find it, they increment that integer. Does that make sense? I want to make sure everyone gets that, okay? Read the letter, and then have a loop that goes through the array until it finds that letter, and then you increment the integer part of that same struct where that letter was. Okay? I'm not asking you to think about code yet at this point, just conceptually, if that makes sense. Can anyone think of a better way to do that? Let's go there. Yes? Uh-huh. Uh-huh. Read a character, convert it to lowercase. Okay, so if we read it, let's stop there for a second. If we read a letter, and then we say that letter minus we convert it to a lowercase letter, and then we say that letter minus lowercase a, what does that give us? Right, it gives us the index. Right, it gives us the index into our array of that letter. Right, so in other words, if the letter we read was E, and we said E minus the character E minus the character A, what does that equal? 4, right? Because E is the ASCII value for E. It doesn't matter what it is exactly, but the ASCII value of E is 4 bigger than the ASCII value of A, right? So if you subtract E minus A, you're going to get 4. And that's good because this array sub 4 is where we want to increment the counter. Okay? I think that's enough hits to get you going on it. Any other questions about that stuff? Okay. Um, all right. Let me just ponder this for a second and see if there's anything else I wanted to say about this. I think that's all I'm going to say for now. Well, we're not using classes in this assignment. Right. Right. All right. Any other questions, specific questions about this assignment or about structs? All right. I think we should. I think we should go ahead and leave that as it is for now. And of course, feel free to ask me for questions on the side if you still have questions. So I'm going to totally switch gears here, and I'm going to go back to talking about arrays and doing some another example with arrays. Last time we did the reverse list example, right? I think that was the last thing we did, and we finished it up. So I just have one more arrays example that I want to do, and that's going to be I want to write a function that takes an array of integers and puts them in order. In other words, the word we use for that in computer science is we sort them. Okay. I'm going to stop for 2 minutes because I need to get something to drink, or I'm not going to make it through the class. So let me just pause the recording here, and I'll be back in a couple minutes. Okay, so I'm back. I hit record, right? Oh yeah. Okay, I did. So I want to write a function that's going to take an array of integers and sort them. So a lot of this code here from our last example, the reverse list example, is going to stay. Really, all we're doing is instead of calling reverse list here, we're going to call sort, right? We're still going to want to read numbers. I mean, we could test our function by generating a bunch of random numbers and then sorting them. That might be interesting, but I'm going to go ahead and stick with just reading the numbers in since I already have this function here anyway. Okay. So I'm actually going to literally just change that to sort and change that to sort. And we're going to write a sort function. Oops. Okay, so now that I've played with my code, I need to take a step back and talk about sorting for a while. Sorting is actually a pretty big subject in computer science. As a matter of fact, you could take a whole class devoted to searching and sorting. Probably like in graduate school or something. So it's fairly important because it's sorting, especially, can be a very time-consuming thing. And so if you get much data, it really starts making a big difference if you write a sort that's really inefficient. So there's been a lot of research into figuring out faster ways to sort and search. So this is just going to be our first shot at it, and a lot of what we will do in an advanced C++ class, or a data structures class will be, there'll be one whole chapter in the text on sorting probably, and maybe one whole chapter in the text on searching. So the search that we're going to do, the sort that we're going to do today trying to decide whether to use paint or not. I think I can just do it like this. Yeah. So I'm going to just give a bunch of numbers up here. 5, 7, 3, 2, 9, 0, 14, 8, 10, minus 2. Okay, there's a bunch of numbers. What I'm going to show you is a selection sort. And the way that the selection sort works is you look through the array, you find the smallest item in the array, and then you swap that smallest item in the array with the first item in the array. Then you move on to the next element of the array. So after one pass of this algorithm, you've got the smallest item in the array at the beginning of the array, and now you only have to look at the rest of the array that's left over, not counting the first element, right? So you look at the first element of that new smaller list. Let me rewind just a little bit. You look through the whole remaining list to find the smallest number that's in that remaining list, because you're not looking at the first element anymore. Find the smallest one and swap it into the new first element. Okay, so let's just go through this process with this. What's the smallest element in this list? -2. So after one pass through this algorithm, you are going to have the following situation. The -2 is going to be there. Everything else just stays where it was. Except at the end you're going to have the 5. Does that make sense what just happened? I just swapped the smallest item in the list with the first item in the list. Okay, so now I know, I'll put like a vertical bar here. I might even put a colon, maybe that'll be more clear. I'll put a colon there to show that I'm done sorting this much of the array. Now I'm only looking at this part of the array. Okay, so for the next pass, I'm going to look at this much of the array, and what's the smallest number that's left? 0. So I'm going to swap the 0 and the 7. So the -2 just stays there. And did I say swap the 0 and the 7? That's okay. Swap the 0 and the 7. Just making sure I didn't mess it up. So the 0 is going to go there. And the 7 is going to go there. And the rest is going to remain unchanged. Okay, so I swapped the 0 with the 7. Now I know that these first two elements are in their correct position. So I'm going to only be looking at the remaining numbers in the list. Okay? All right. We're going to do that again. What's the smallest remaining number? 2. So I'm going to swap the 2 and the 3. Oops. And now I have the first 3 elements are in the correct position, so I'm going to put a colon there. there's no way for us to know. There's no way for the computer to know that that is the first. That's the smallest item left, without looking through the whole array. So, I mean, we can look at it and say, oh, we don't have to do the next step because that's the smallest number left. But the computer has no way of doing that. So, I'm going to have to look through the whole array, the whole remaining part of the array. The smallest item I'm going to find is 3, and so I'm going to swap the 3 with itself. Okay, so minus 2, 0, 2, 3, and then that the first 4 positions are now sorted, and I can just put the rest down. Okay, get the idea? So I'll try to speed it up a little bit, I guess, here. So the next one, the smallest item left is the 5, so I'm going to swap the 5 and the 9. Five and the 9. Oh, hold on. So, and then the other numbers, the 7, the 14, oops, the 8, and the 10 aren't going to change. And I had swapped the 5 and the 9, so this is going to be a 9. Okay. Now I've got this much of the array left. The smallest item is 7, so I'm once again swapping with myself, which means I can just copy the whole thing. And the only thing that changes is where the colon is, right? That makes sense? I just swapped the 7 with itself. Now I've got this much left. So I find the smallest item is 8, so I'm going to swap the 8 and the 14. So instead of 14, I'm going to have 8. Instead of 8, I'm going to have 14. And now my colon goes here. Why does that seem... Oh, okay, the 14 took the place of the 8, so it should be like that. Okay. And now I've got 3 items left. The smallest one is 9, so I'm going to swap the 14 and the 9. So this is going to become 9. This is going to become 14. And I put the colon here. Okay. Now I've got, did I do that right? The gaps are kind of freaking me out here. So, then I've got 2 items left. I find the smallest item. The smallest item is 10. So I swap the 10 with itself. So the only thing that changes is just that I have the colon goes there. And then, what now? Swap the 14 with itself, or can I just stop now? I can just stop now, right? When there's 1 item left in the list, I can stop. Okay? Any questions about that process conceptually? So the only question is now is how to turn that into code, right? So let's take a look here. Should the array be passed by reference? Arrays are always passed by reference. Unless you say const, yeah. Technically, Even if you say const, it's still passed by reference. It's just passed by reference, but you can't change it. That make sense? I know it's kind of confusing. Okay, so any ideas how to get started here? Remember, we're going to do top-down programming now, so we're going to start with the big picture and then try to drill down to the details. So the big picture perspective here is what? We've got to do a certain number of passes through the array, right? How many of those steps? So if one step is looking through the array, through the remaining array for the smallest item, let me try that again. Searching through the remaining array for the smallest item and swapping it with the first item in the remaining array. That's one step, right? How many times do we want to do that step? Close, the other way around. However many items there are, minus one, right? Because we don't have to do it for the last item. So should we just start with a for loop for int count, get 0, count less than num items minus 1, count plus plus. Yeah. Yeah, it was for my old example, and then I just modified it a little bit because almost everything's going to be exactly the same for this example. So everything's exactly the same except I just changed the word reverse list to sort. Okay, so here's our for loop. Each time through this for loop, what do we have to do? Search the array for the smallest number. Search the remaining array for the smallest number. And then swap that with the first item in the remaining array, which would be array subcount, yeah, or list subcount, right? So that's still kind of a lot, right? I don't want to write all that code right here. I want to figure out a way to describe what I'm doing, and call another function to have it do some of those details. So let me put what we've been saying a different way. All we're going to do now is we are going to swap the smallest item in the array with the first item in the array, or the remaining array. Okay, so I'm just going to type that. Swap. How am I going to say the smallest item in the array? Here's how I'm going to say it. List sub. Do I know what the index is of the smallest item in the array? No, I don't know that, but I could write a function to figure it out, right? So how about list sub index of smallest? This is a function we had in our last program, right? So we're just going to steal it over here. I shouldn't have erased it. Index of smallest, list count of items. All right, so okay, so far I'm going to swap the smallest item in the list, and the way I'm going to find the smallest item in the list is I'm going to have a function call that returns the index of that number, and then I put that index in here in my list array to access the list array. Yeah. Well, I'm not quite done, right? When I say swap, I have to swap two things. So this is the first thing I'm swapping, so there's going to be a comma here, and then the thing I'm swapping it with. What am I swapping it with? List sub count. Okay, stare at that for a second. Why do we need count here? We're finding the index of the smallest item in the array. Why do we need count? Yeah. To know where to start looking in the array, right? That tells us, remember we have this concept that I kept repeating over and over again about the remaining array? That's how we know which part of the array we're still looking at. So if count is 3, that means we're looking at all of the elements in the array starting with list sub 3, right? Okay. Any questions about our sort function? Okay, so we still have to do index of smallest, right? It's almost exactly like one we've already done. So I'm just going to put it down here. Let me list these so you can see them. Okay, so int target, oops, int target index, starting index, int count gets starting index. I should have had you guys work this out. Oh well. List 1, count less than items, count plus. Okay. That part, does that, the way I've set that for loop up, does that make sense? So I'm going to start off by saying the index of the smallest. So when I say target index, what I'm saying there is the index of the smallest that I've seen so far. Okay. Maybe I should call it. I'll leave it. So I'm saying, okay, let that equal the index where we're starting, and then starting with the next element after that, so starting index plus 1, go through the array. Does that make sense? Okay, so each time through the array, what we have to do is we just have to say, okay, if this item I'm looking at is less than the smallest I've seen so far, list sub target index, then reset the target index, right? Okay? Right. Now, yeah, so I have to return target index. How's that look? I don't like the name target index. I should come up with something different. No, you can't call it. I probably don't want to call it index of smallest because I've already used that. Anyway. Okay? So now I've got this function that returns the index of the smallest item in the array. And in my sort function, I'm just saying swap that item with the first item in the array. Yeah. Ah, good question. Under the struct. We don't have a struct here. In your program? I'm not sure what you mean by under the struct, but let me just, We could fairly easily write a swap function. It would just be 3 lines of code, right? We can't just say x gets y, y gets x, because when we say x gets y, we've destroyed whatever x used to be. So we have to store x someplace first. So temp gets x gets y, and then y gets temp. Anyway, wouldn't be that hard to write. However, C++ already has a built-in swap function, and so we're just going to use that. Okay? Actually, C++ also has a built-in sort function, but we're not going to use that. Technically speaking, if we're going to use that swap function, we should say # include algorithm. Okay? I think, however, that most compilers, it would work anyway, even without that. So, but best to go ahead and include that. All right, am I done? I need a prototype here. I think I'm done. So let's try it. I think it just looks funny because I put it on the multiple lines there. What was my error? I think I have too many. Oh, I don't have an open curly brace here. So I'll just use the same numbers that I used in my example. 5. Well, I can't because if I enter a negative number, it quits. 7, 3, 2, 9, 1, 14, 8, 10, 0. Did we never figure that out last time? Yeah, I know. I'm just. Oh, even before that. Huh. What could that be? All right, so I need to enter fewer numbers. 5, 7, 3, 2, 9. One more? 0. That was good enough. Okay. It did sort them. Oops. Sorry, I shouldn't have made that go away so fast. Trust me, it sorted them. All right, any questions about that? Okay. So you're going to use essentially this same function in your in the assignment you're working on. You just have to switch things around a little bit because you're sorting structs instead of ends. What was I going to say? So let's. I want to just kind of give you a quick. We just have a few minutes left, so maybe I can give you a quick example of some other kinds of sorts. Okay, so that's a selection sort. Oh, I know what I was going to say. I think in the textbook you're going to see a selection sort written completely differently. It's exactly the same algorithm, but it's written totally differently. It's written just with in one function instead of 2 like I've done it, and nested loops and things like that. So it might be interesting to take a look at it, see which one you like better. That's not what I wanted. Let's take another look at that list of numbers that I had. 5, 7, 3, 2, 9, 0, 14, 8, 10, -2. Okay, so I want to, I'm going to show you bubble sort. How many people have already heard of bubble sort? Bubble sort, yes. No one. Okay, well, one maybe. So basically a bubble sort is you go through each pass through the array. It's going to be very similar to selection sort in that you're going to have to go through the array however many times there are elements in the array. Okay, but this time each pass through the array, I'm going to just go through and compare adjacent elements, and if they're in the wrong order, swap them. Okay, so I look at the 5 and the 7. Is that right or wrong? That's already right, so I'm going to put 5. Then I look at the 7 and the 3. Swap them, right? That makes sense why I'm swapping the 7 and the 3? They're in the wrong order, so I swap them. Now I've got 7 and 2. What do? Swap them. Now I've got 7 and 9. Leave them. Now I've got 9 and 0. Swap. Now I've got 9 and 14. Leave. Now I've got 14 and 8. Swap. Now I've got 14 and 10. Swap. Now I've got 14 and -2. Swap. And now now I'm done. So 14's there. Yeah. Yeah. Is it gonna? Well, it didn't do that this time, right? Eventually it will, right, eventually. But what we're saying now is that on each pass, one thing that we know for sure when we're done with each pass is that the largest item in the array is now at the end of the array, which is where we want it. So the second pass, we'll put the second largest number into the second biggest, so and so on. So what that means is that, well, let's go ahead and go through this again. I'll try to go a little faster, but 3 and 5, I'm going to swap. 5 and 2, I'm going to swap. 5 and 7, I leave. 7 and 0, I swap. 7 and 9, I leave. 9 and 8, I swap. 9 and 10, I leave. 10 and -2, I swap. And I'm done. So one thing about bubble sort is that I could have kept going, right? I could have just kept saying, okay, now 10 and 14, I leave. But if you write it carefully, you can make it so that it just stops when it gets to the part of the array that it already knows is in the correct order. Yeah.
I'm sure I'm understanding this version of the sort is doing. You're swapping the biggest ones to the end.
That's the end result of going through the array one time.
But what is it actually doing?
So what it's actually doing is that I'm comparing each pair of adjacent elements, and if they're in the wrong order, I'm swapping them. So here, on the first pass, I did the 5 and the 7. They were in the right order, so I left them. I left the 5 there, and I left the 7 there. Okay, so I had 7 and then 3. So then I compared the 7 and the 3. They're in the wrong order, so I swapped them. I put the 3 here, and I put the 7 here. And I just keep doing that. Compare the 7 with the 2. That's the wrong order, so I swap them. Okay, and what that does in the end is it puts the biggest number at the end, but the thinking behind this is that it also sort of puts the rest of the numbers in a little bit of a better order than they were before too. Does that make sense? Sort of at the same time. Question? Do you have to? Why would you keep track of the number of times you've swapped? Right. So you could have a bubble sort. So the question is, should we keep track of how many swaps we've done? And the answer is, it depends on how sophisticated we want to make our bubble sort. Right? So we could write our bubble sort so that we don't keep track of that and it just keeps going. Even if the list already happens to be sorted. Well, we know that each time, okay, so the question is, how do we know when we're done? Remember with selection sort, each pass through the array, we swapped the smallest number to the beginning, and then we knew we could ignore that first part of the array. Exactly the opposite is happening here. Each time through the array, the largest number in the array is going to the end, and so we're just going to focus on what's left in the array. So if I know that I'm getting the biggest number to the end every time, how many times am I going to have to do this? None items minus 1, and then I'm done. Okay. Now, if you want to, so for example, if you're in a situation where you're writing a bubble sort and you know that there's going to be lots of times when the data is already sorted or almost sorted, so that it might only take 2 or 3 passes and then everything's done, it might be worthwhile to get a little more sophisticated and count how many times you swapped, because if you swap 0 times, you're done. If you go through the whole list and you didn't have to do any swaps, that means that it's already sorted. Okay? We're not going to do that here. At least not this time. That's what this sort is called, yes. I think the reason is that you're sort of bubbling the largest number up to the top, right? Sort of like bubbles. So, okay, let me just, so now I guess I should use my colon thing like I did last time. Okay, so after 2 passes, I know that the 2 biggest numbers are in the correct position. So I'm going to go through again. I have to swap the 2 and the 3. Don't swap the 3 and the 5. Swap the 5 and the 0. Don't swap the 5 and the 7. Don't swap the 7 and the 8. Don't swap the 8 and the 9. Swap the negative 2 and the 9. And I'm done. Okay. Let's do it again. 2 and 3, don't swap. 3 and 0, swap. 3 and 5, don't swap. 5 and 7, don't swap. 7 and 8, don't swap. 8 and negative 2, swap. And I'm done. Okay, so notice every time we go through it, we're getting the next biggest number into this end part of the array. 2 and 0, swap. 2 and 3, don't swap. 3 and 5, don't swap. 5 and 7, don't swap. 7 and negative 2, swap. And I'm done. Did I miss something? Okay. Now, I'm going to just make another observation about this, right? What's happening with the negative 2? It's gradually getting pushed towards the front of the array. So this is the worst possible situation for bubble sort, because the smallest item started off at the very end of the array, and each pass through the array and only gets swapped one closer to the front. Okay. Normally with bubble sort, we would we would get done with fewer passes through the array. Okay, 0 and 2s don't swap, 2 and 3 don't swap, 3 and 5 don't swap, 5 and -2 swap. So basically we're done except that pesky -2 is in the wrong place, right? 5. Huh, there we go. Nope, that's not what I wanted, huh? I want okay, getting closer. 0 and 2 don't swap. 2 and 3 don't swap. 3 and -2 swap. And actually, I'm done there. Okay, almost done. Hang in there. 0 and 2 don't swap. 2 and -2 swap. And 0 and -2 swap. And now I am done. And the reason I know I'm done is that there were 10 numbers in here, and I've done 1, 2, 3, 4, 5, 6, 7, 8, 9 passes. So I'm done. Okay. All right. I just wanted to show you that. I don't think, at this point anyway, I'm going to take the time to actually write the code for that. It's not too bad. You could probably figure it out. It's kind of similar to the selection sort, except you don't have to find the smallest item. You just, inside your for loop, you just start swapping things. Any questions? All right. I'm done.